Welcome back to the deep dive. We have a really interesting stack of documents on the table today because on the surface, we're looking at something that seems incredibly mundane. I mean, honestly, if you walk past this in a shop, you wouldn't even look at it
No,
twice.
not at all. It's a yellow can. You'd see it on a dusty shelf in a garage and just assume it's some generic spare part.
Exactly. It's a metal canister, painted yellow, fits in your hand. And according to this listing we have from Industrial Stop, it costs exactly $34.77.
Right.
But the deeper I got into the specs and the more I read about the engineering behind this little thing, the more I realized we're not just looking at a spare part.
No, you're looking at a $35 insurance policy for machinery that costs millions of dollars.
That's it. That is exactly the right way to frame it. It's the gatekeeper.
It is.
So today's deep dive is on the Cat 1R-0756 diesel fuel filter. And look, I can hear you already thinking a deep dive on a fuel filter. Seriously.
It sounds a bit niche, doesn't it?
It does.
Hmm.
But the whole mission today is to figure out why these tiny design choices, or we're talking about things like, acrylic beads and nylon tubes, why they actually matter when you're trying to, say, keep the lights on in a hospital.
Or keep a massive cargo ship moving across the ocean. It's a case study in precision engineering, really.
How so?
Well, we always focus on the big engines, right? The horsepower, the torque, the sheer size of them. But none of that works if the fuel isn't clean. And when we say clean, we are not talking about looks clean.
No.
We're talking about a microscopic level of cleanliness that is, well, it's hard to even picture.
Okay, so let's unpack this. Our source today is the detailed product spec and sales listing from Industrial Stop. It's got technical attributes, compatibility lists, all that stuff. But I want to start with the core problem. The source calls this an advanced efficiency fuel filter. I have to ask, is that just marketing fluff, or is there a real mechanical difference here?
Oh, it's a huge distinction. And it's not just marketing talk. The source makes a point of contrasting this advanced efficiency model with standard filters.
Okay.
The primary function of any filter is to get contaminants out, sure. But the text here notes that while all filters remove some particles, a lot of competitive or, standard filters, they fail to capture the specific tiny particles that cause the most harm.
Right. The source uses this phrase, sensitive fuel system components. That really stood out to me.
Yeah.
I'm not talking about like an old lawnmower engine here.
No, absolutely not. These are high-pressure, high-performance systems. Modern diesel injectors, they operate at incredible pressures. Thousands and thousands of PSI. The tolerance for any kind of dirt is basically zero.
And if you let those fine particles through, the ones a standard filter might miss?
You're essentially sandblasting the inside of your fuel injector.
Sandblasting. Wow. That is a terrifying image.
It is. And it's an erosion that happens slowly over time. So you might not even notice it at first. The engine will still run, but you're losing efficiency, you're losing power.
And eventually, boom. Component failure.
Exactly. Which brings us to the value proposition that's mentioned in the source. It says using this advanced filter gives you superior protection, which they link directly to the bottom line.
Yeah, they mention extending machine life and even increasing the resale value. That part really surprised me. The idea that a $30 part could affect the resale value of a giant mining truck.
Well, think about it if you're the buyer. You're looking at a used generator, a used piece of heavy equipment. If the maintenance logs show it's always been run with genuine advanced efficiency filters, that tells you something, doesn't it?
Yeah, it tells you the insides haven't been getting sandblasted.
Right. It's a proxy for the internal health of the machine. It signals that the previous owner didn't cut corners on the stuff you can't see.
Okay, so that's the why. Keep the microscopic junk out. Protect the expensive metal. But this is where I want to dig into the how, the anatomy of this thing. Because the source lists some specific features that honestly sound almost counterintuitive to me.
Let me guess. You're looking at the center tube.
I am. The spec sheet highlights a non-metallic center tube, and it says it's made of nylon. Now, I'm not an engineer, but usually when I think heavy-duty, industrial strength, Caterpillar, I think of steel, I think aluminum. Why on earth are they using plastic?
It does sound backward, doesn't it? You expect heavy metal, but it's actually a brilliant solution to a very specific and kind of sneaky problem.
Which is?
The source says the nylon tube prevents metal contamination.
Wait, metal contamination from the filter itself.
Exactly. Think about how a standard metal filter tube is made. It has to be cut, machined, maybe welded. That whole process can leave tiny little burrs or metal shavings behind.
Okay.
Or, over time, inside the can where you can't see it, that metal could rust, depending on the fuel quality.
So the very thing that's designed to clean the fuel could actually be dumping metal particles into it.
Precisely. It's a total paradox. The filter becomes the villain. So by switching to nylon, they remove that risk entirely. Nylon doesn't rust. It doesn't have metal burrs. The filter cannot be the source of that specific contaminant.
But is it strong enough? I mean, we just talked about the insane pressures in these systems. Can plastic really hold up?
Oh, yeah. Modern industrial nylons are incredibly tough. They can handle the pressure without collapsing. The source even says it's cleaner and stronger than metal for this exact job. It's all about using material science to solve a risk you wouldn't even think of.
All right, I'll buy the nylon argument. It eliminates the self-contamination risk. But the next one really threw me. Acrylic beads.
Ah, yes, the beads.
The source says they're there to prevent bunching. I had to just pause and picture that. Bunching. Like a sock in your shoe.
A little bit, yeah. But inside the can. So, okay, picture the inside of that canister, the actual filter material, the paper-like stuff. It's pleated, it's folded back and forth like an accordion.
Right, to get a huge amount of surface area into a small space.
Exactly. More surface area means it lasts longer and holds more dirt. But here's the problem. Fuel is being pumped through that can at a really high pressure.
And that pressure pushes on the pleats.
It pushes hard. And without something to hold them apart, the pleats can get pushed together. They bunch up.
And if they're all smashed together, the fuel can't get through those parts.
Right. You lose all that surface area, you get dead spots. And now you have another problem. If half your filter is blocked, all the fuel has to force its way through the parts that are still open.
It creates a channel.
Yes. And when the flow rate gets too high in those channels, it can actually push dirt right through the filter paper. It just blasts it through.
So the acrylic beads are just spacers.
That's all they are. They're rigid little spacers glued onto the pleats. They keep the accordion open. The source says they prevent bunching to ensure uniformity, and uniformity is the holy grail of filtration. You want fuel flowing evenly over every single square inch.
It's wild that tiny plastic beads are the difference between a working filter and a failing one.
A tiny detail that solves a massive fluid dynamics problem.
And speaking of holding things in place, there's another term here that sounds like a dance move. Spiral roving.
Spiral roving. Yeah.
The source says it gives greater pleat stability. Is this just doing the same thing as the beads?
It's attacking the same problem, but from the outside. So while the beads separate the pleats from each other on the inside, the spiral roving wraps around the outside of the whole filter pack.
Okay.
It's usually a fiberglass thread. Think of it like a belt or a girdle. It keeps the whole structure from flexing and fluttering.
Fluttering.
Yeah, engines rev up and down, right? The fuel pressure changes. If the pleats are moving back and forth, fluttering, that movement can actually shake dirt loose that the filter has already caught.
Oh, that makes sense. Like shaking out a dusty rug.
Exactly like that. The dirt can work its way through the media if the media itself is moving. The roving just locks it all down. That's why the source connects it to maximum dirt holding capability.
It is amazing how much engineering is going on inside this little can. We haven't even mentioned leaks. The source talks about molded end caps.
Right.
Now, that seems like a pretty low bar, doesn't it?
Yeah.
By our filter, it doesn't leak. I would hope no filter leaks.
You'd be surprised. It's all about how they're built compared to cheaper filters. In a budget filter, the end cap, the top and bottom, is often a separate metal disc that's just glued on.
And glue can fail.
Glue can fail. Crimps can have gaps. A molded end cap means the material is poured into a mold with the filter paper, so it becomes one single fused piece. It eliminates any path for fuel to sneak around the filter.
Because if it leaks past the filter media inside the can...
It's just unfiltered fuel heading straight for your engine.
Okay, so to recap the anatomy. Nylon tube, no self-contamination. Acrylic beads keep the pleats open. Spiral roving, strap it all down so it doesn't flutter. And molded caps to seal it.
All wrapped in a strong one-piece can for $34.
It really puts the price in perspective. So let's talk about what this thing actually fits into, because I'm looking at the compatible models list, and it is extensive. It's just a wall of text.
It is a huge list, but there's a pattern in there. It's versatility within a very specific class of heavy machinery.
I see generators first. SR4, SR4B, SR5. What are we looking at there?
Those are serious power generation units, not the little generator you take camping.
Right.
These are the size of a shipping container. They power hospitals, data centers, huge construction sites. If the power goes out, that SR4 has to kick in instantly.
And if the fuel filter fails.
The generator stalls, the lights stay off, it's critical infrastructure.
Then under petroleum products, the 3500 series, 3508, 3512, 3516.
Ah, the 3500 series, legendary engines. In oil and gas, these are the absolute workhorses. They run drilling rigs, fracturing pumps. A 3516 is a massive V16 diesel. These things run 247 in the harshest environments on Earth.
And speaking of harsh environments, there's a marine section. Same engines.
Great. Tugboats, offshore supply vessels. I mean, think about the safety there. If you lose an engine on a tugboat guiding a massive tanker into port, that's a disaster.
And then industrial, C27, C175, 16.
The C175 is a beast. That's the engine in those house-sized mining trucks. The ones with tires twice as tall as a person.
Wow.
We're talking about machines that cost millions and millions of dollars. And they all rely on this one filter.
But there is a catch. The source has this disclaimer in bold. All fitment filter part numbers are based on your engine serial number.
That is the golden rule. Always. Never assume.
So even if I have a 3D512 engine, I can't just buy this blindly.
No. An engine made in 1995 might have a different filter head than one from 2015. A marine version might be configured differently. They evolve, they change fuel flow rates, pressures, to meet new emission standards.
So if you force the wrong one on?
Best case, it doesn't seal right. Worst case, you get a fuel leak right next to a hot engine. That's a fire hazard.
So check the serial number.
Always check the serial number.
Now let's talk competition. Because Industrial Stop lists a whole section of cross-references. I can get a Baldwin, a Fleet Guard, a Wix.
Right, Napa's on there too.
So here's the question every procurement manager on the planet has to ask. Why not just buy the cheapest one? If the Wix is $5 cheaper and I'm buying 100,
yeah,
that adds up.
That is the eternal question, isn't it? And look, Baldwin, Fleet Guard, Wix, they're all reputable brands. We're not saying they're junk. They'll screw on, they'll filter fuel.
But the source text is pretty aggressive on this point. They call it the Caterpillar argument.
Yeah, they don't mince words, do they? Caterpillar testing proves cap fuel filters provide superior protection. They're making a system argument.
The system argument.
They're saying, we built the engine, we know exactly what its tolerances are. A competitor's filter might fit, the threads match, but does it have the acrylic beads? Does it have the spiral roving? Is the micron rating exactly the same?
So the competitor might be good enough, but CAT is claiming optimal.
Exactly. And remember that resale value point. If you're a fleet manager, sticking with genuine CAT parts is it's a risk management strategy. If an engine blows up and you're using a generic filter, there's always that question.
Was it the filter?
Right. If you use the specified CAT part, that question just goes away. It's peace of mind. And when downtime on an oil rig costs tens of thousands of dollars an hour, peace of mind is pretty cheap at $34.77.
Let's look at the logistics here. Industrial Stop lists it as in stock with free shipping. They also mention bulk pricing. Who's buying these?
Both, really. It's for the owner-operator, the guy with his own tugboat who can now just click add to cart and get the same part as a global mining company. But yeah, mostly fleet managers are buying these by the pallet.
And they're not just buying this filter. The source lists related products that paint this whole maintenance ecosystem picture.
Right. You see the 1R-0749, the 1R-0750. A lot of these big engines have a two-stage filtration system.
And I see the fuel water separator listed.
That's critical. Diesel absorbs water from the air. Water will destroy an injector even faster than dirt will. So the fuel goes through the water separator first. That's the bouncer. Then it goes to the 1R-0756.
So this one is the final polish.
It's the goalie, the last line of defense.
Then I see the engine oil filter, the 1R-1808, for about $47. So for under $100, you're refreshing the vital filtration on a massive machine.
When you compare that to the cost of the fuel, the oil, or the downtime.
Yeah, the filter cost is basically a rounding error.
What's the big takeaway for you in all this? For the listener who maybe doesn't own a 3512 engine, what's the lesson here?
For me, it's the concept of hidden complexity. We see the big machine moving, we hear the noise, we see the power, but the actual reliability comes down to these silent, static components. The fact that engineers spent years probably figuring out that nylon was better than metal for that tube.
It's a reminder that good engineering is about what doesn't happen.
Exactly. The engine doesn't get contaminated, the pleats don't bunch, the fuel doesn't leak. Success is boring. I love that. Success is the engine just running. Failure is what's exciting and expensive.
And this $35 can is just a purchase of boring reliability. You are buying the absence of problems.
So to summarize what we've learned today, The Cat 1R-0756 is not just a yellow can. It is a piece of sophisticated engineering.
It's got a nylon center tube to prevent that paradox of the filter making the fuel dirtier.
It has acrylic beads to act as spacers, keeping those pleats open for uniform flow.
And that spiral roving the girdle to lock the pleats down so they don't flutter and release dirt.
It fits a massive range of critical engines, but you have to check your serial number.
And while you can buy a competitor's version, the source argues that for true protection and resale value, the genuine article is the safer bet.
Because at the end of the day, you're not paying for the filter. You're paying for the engine to keep running.
Well said.
So here's a thought to leave you with. We spend so much time worrying about the big things, the big projects. But so often, it's the microscopic contaminants that can bring the whole system down. And it's the invisible, well-designed safeguards, like those little acrylic beads inside a dark metal can, that keeps everything moving.
That is a deep thought for a fuel filter.
That's what we do here. If a simple fuel filter requires all this tech just to hold dirt effectively, just imagine the level of unseen complexity hiding in the other machines, or even the software that we rely on every single day. What other acrylic beads are keeping your world from bunching up?
I'll be thinking about that one.
Thanks for listening to this deep dive. We'll catch you on the next one.